Bismillahirrahmanirrahim. Assalamu alaikum, respected keynote speakers, invited speakers, uh, panel discussions, and respected participants. I am Professor Dr. Noman Islam from Ikra University. Welcome to the NeurIPS Meetup organized by ALADIN Solutions and 34th International Conference on Neural and Information Processing System. This meetup comprises different keynote speakers from all over the world in two invited speeches, and then we will have a panel discussion on the topic of education in the context of fourth industrial revolution. That ends the first day, and in the second day of the meetup, we will have three workshops on TensorFlow, Python, and web scraping. These workshops will be delivered by well-known persons from academia and industry. It is to be noted that around 1,500 students have registered for these workshops. So I hope this would be a big success. And again, thank you very much for all the participants, keynote speakers, and invited speakers and panel discussants to join this meetup. Now let's move to the uh, first part of the meetup. I would like to invite Professor Dr. Tariq Mehmood from Institute of Business Administration, Pakistan, to present his keynote speech on the topic Concept Drift in Machine Learning for Streaming Data, a systematic literature review. So, Dr. Saab, please continue.
Okay, Assalamu alaikum, and thank you, Professor Noman, for inviting me for this event. I hope you can see the screen here.
Yes, sir.
Okay, okay. So, just a bit about myself. I have a PhD and MS in machine learning from Europe. I research in the domains of big data, analytics, deep learning, and data science, or you can call it machine learning. I have consultancy and training experience of more than 10 years in Pakistan. And one of the things that we have done is that I was, Alhamdulillah, able to design this diploma for big data analytics in IBA. So this is being offered by the ICT department, the Center of ICT. We have these 6 courses, which are all hands-on courses on the big data environment. So we're actually teaching all of this in the big data environment. That is, you can say, on Hadoop and NoSQL databases. And currently, it's the 5th batch, which is being taught in this diploma. So it's a very successful diploma, Alhamdulillah, especially for the Pakistan industry. So I invite you all definitely to look this up and propagate in your circles. So my topic today, as it is written here, is concept drift in machine learning of streaming data. So first, let us understand what is actually machine learning or data science, as we call it in the industry these days. So this is the life cycle which has been proposed by Microsoft a few years ago, and so the data science or machine learning process starts actually with a problem. You have a business problem, and in order to understand that problem, you get the business knowledge, and the business knowledge is to be taken up by the analytical team, because the business already has knowledge of that. So the data analytics guys and the data scientists, they are supposed to conduct interviews and read lots of online literature to understand how the business runs. For example, if you want to do inventory management for a retail company, then you have to understand that how the retail business works. Once that happens, you are in a position to actually acquire the data and understand it. So you can go to the IT department, and you can then understand the databases and the tables that are there. and you have to understand that data through basic statistical analysis like exploratory analysis like box plots and probability distribution analyses, etc., etc. And for that you have to make a complete pipeline, because you have to repeat this process again and again. And you can develop your environment for analytics either on the cloud or, for example, in-house. Once you acquire the data and understand it, then you obviously want to make predictions over that, and that is the modeling part. For the modeling part, you can select the relevant features through feature engineering. So there are many techniques there. Then you can select many algorithms, like for example bagging algorithms or boosting algorithms these days are typically giving a good performance. And then you can evaluate the model, for example, by using precision, recall, accuracy, RMSE, etc., etc. And then when the modeling is completed and you are satisfied that your model is giving a good performance on the test set, then obviously your work is to deploy the model within the business operations, within the actual stream of data which is affecting the business. So the model has to be deployed on some server, and that server is basically going to offer predictions from time to time, and the customer is saying, okay, okay, everything is fine, and the process ends. In fact, the topic of my conversation today is that this process does not end here. This diagram is wrong with respect to that, because machine learning never ends. And the problem that here I have told you that this is not the end, in fact. And the problem is that the end is not there, because you're supposed to execute this data science life cycle uh, for several years, right? Uh, if any company wants to implement a predictive model and they get it implemented, then they're not going to stop like just on once. Like the model makes a prediction once after deployment and they're happy. They will at least want to use the model for 3 to 4 years. And for that, the problem is that the data that is coming here, data acquisition and understanding, the data can change. And all of us know that machine learning is basically a mapping from a set of input data to a class label. That's a very basic concept that everyone knows these days. So the problem is that the data that is coming in, on which you trained and modeled all these algorithms, the probability distribution of that data changes. So the relationship between the set of input attributes and the output class label basically changes. So at different times, you're going to have a different distribution, and that means that the algorithm that you learned here the first time might not be applicable later on. Like maybe after 6 months, that algorithm is not there because the performance of the machine learning model starts to decrease, and your model is not trained to learn on the new data. So you in this diagram, Microsoft has not given any solution to this problem, that what if the data distribution changes from the back and there's a concept drift. And the concept drift means exactly that the class distribution changes. So the relationship between the input and the output changes, and your algorithm that you learned the first time is now not applicable on the new data, and hence the performance of predictions is going to go down. So accuracy is going to go down, precision is going to go down, and you need to come up with a way to understand how to cater with this problem. So the first thing that we want to do is that we want to detect the drift, that what are the signs that a drift has occurred. That's the first thing we want to do. And the second thing we want to do is that we want to adapt to this drift. So I want to update my model so that the new data, because if a new data is coming with a different distribution, then I want to retrain my model so that it adapts to the new distribution. That's it. So we have two things. Then one, we have to detect the drift, and the other thing is that we want to adapt to the drift. So I hope that this is clear up to now. If you have any questions, then you can interrupt me. I have no issues with that. So these are the four types of drifts that can occur for a single class. One is a sudden drift. So the blue represents what on which you learn the model the first time, the original probability distribution, and the red actually represents the new probability distribution. So that is, for example, t plus 1, and this is the distribution at time t. Okay, and the sudden drift occurs exactly like this. The suddenly the distribution changes, and it is going to continue like that. In a gradual drift, it starts to change slowly, slowly. It comes back and then goes to the red one again, but eventually again it turns out that everything becomes red. That's a gradual drift. An incremental drift, there is no there's no alternating between blue and red. So it just starts to get a bit dark blue and then darker blue and then red and then it goes there. That's an incremental drift. And a reoccurring means that sometimes you have blue, and maybe like once a year you have a red pattern, then for the next 11 months you again have a blue pattern. So that's sort of a cyclic or a seasonal pattern. So that these are the four types of drifts that have been detected in the research literature: sudden, gradual, incremental, and reoccurring. So I have thought of some examples for these. So in the sudden, for example, in case there is a strike at the government level, or there's a strike by a large population of people, and you are running a business for a courier service, and you want to make predictions that when is your consignment going to reach. So the probability distribution for that prediction is going to change in the case of a strike. So the data that you are going to put in your model right now is the data for the strike, and therefore your model is not adapted to a strike situation, and therefore it's gonna give very bad results, because the data has changed completely, and that's an example of a sudden drift. In the case of this gradual drift, the gradual drift is, for example, if you're running an e-commerce business and you got a new competitor, so slowly, slowly people start to go towards that new competitor. That's the situation. So sometimes they're going to go, then they're going to come back to you, then they're going to go there again, and then back and forth until finally they just select the competitor. And your sales obviously are not, your input data does not cater for a new competitor, therefore the predictions are going to go down. In the case of this incremental drift, it's like when you do a merger with a company. So when you do a merger, then your data changes, and your predictive models have not been updated, obviously, suddenly. So if you are running a marketing campaign to predict the customer response, then that customer response due to a merger, your model is going to decay its performance slowly, slowly. It's not going to be like that because it's a merger and the data is there. So slowly the new data, it keeps up its pace, and suddenly it's all red. It's all red. It's not the gradual situation, because of the fact that when you do a merger, then your data streams are integrated, and because your predictive models are not catering for the integrated model, so slowly, slowly they're gonna incrementally go towards the red probability distribution. And in the case of a reoccurring, this is a seasonal or a cyclic pattern. For example, you are predicting your sales regarding the tourism industry, and in August, for example, each year there is a specific batch of tourists which come, and your model does not cater for them exclusively. So then this red means that your probability distribution changes, and at least for the month of August, your predictions are not going to be on mark. So these are the four types of concept drifts. We have the sudden drift, gradual drift, incremental drift, and the reoccurring drift. So that's for a single class. Um, if we talk about the
Sorry, Dr. Mehmood, I want to ask Dr. Noman that is there any chance for recording that session, or is it not?
Yes, yes, we are recording. Thank you.
thanks. So in this slide, I have showed the drifts with respect to the global data distribution. So this blue and the blue circles and the black circles represent two classes, and a stationary drift occurs, when the shape of the distribution, global distribution, changes, but the inherent pattern remains the same. So you can see that on the one side I have the black circles, on the other side I have the blue circles, and similarly this was the case even before the drift occurred. So on the one side of the line I have black and blue facing each other, so there is no overlapping. It's just that the position of the dots has changed, so the concept has changed, but the global distribution remains the same. So that's called a stationary drift, and that is much easier to manage, obviously, as compared to a non-stationary drift, in which you can see that the global distribution is changing. So in this case, some blue circles have appeared here, which were not there in the previous picture. So the global distribution is changing, the shape is changing, and this is much difficult to manage. That's called a non-stationary drift. So what we can do is that we can, all of these four drifts, sudden, gradual, incremental, and reoccurring, can be applied to either a stationary drift situation or a non-stationary drift situation. So non-stationary drift occurs when we don't have the labels, because in a machine learning problem, we always assume that we have the labels, and we can use the labels to find out when the drift has occurred. Okay, but in the case of an unsupervised learning scenario, we don't have the labels, and we still want to make a prediction, but we don't have the labels, and we still want to detect whether a drift has occurred or not. So the for the non-stationary situations, we have the unsupervised learning scenario, and for a stationary drift situation, it's more congruous with a semi-supervised or supervised learning scenario. In any case, we don't need to go into the complexities. We just need to basically understand these four types of drift. And even these things make the situation very complicated, because I do not know that in my data which type of drift is occurring, and how should I evaluate that with respect to a stationary drift or a non-stationary drift. So I need to do lots of experimentation in that. So in this work, basically this is an MS thesis work that I completed last year, in fact this year, sorry. So we wanted to find out the algorithms that have been used to detect or identify the different types of concept drift. That's the first thing. um, and then there were two research questions regarding the unlabeled data streams. Like I told you that when I have a labeled data stream, then it is easy that I have the labels. So if a drift occurs and the performance of my classifier goes down, I have the labels to cross check that, and I can say, okay, the performance is going down, so possibly a drift has occurred. So let's retrain the model. So that's easy. But what if I don't have the labels of new data which is coming, and the industry does not have the label for new data, because the industry wants us to predict the data for the labels which is coming today. They don't have the labels in advance, so I cannot I cannot have a supervised drift detection scenario in the industry. I need to have an unsupervised drift detection scenario. So in this case, first we wanted to find out what are the different types of algorithms or the famous algorithms for detecting concept drift. And then we wanted to investigate that if I have unlabeled data, then the approaches that have been used to detect the concept drift in unlabeled data, how do they match with the research literature in which the labeled data is there? Okay, so is the accuracy good? Are the algorithms performing in a good way, etc., etc.? And a related question is, how do you actually do it in an unsupervised scenario? So what are the algorithms for doing that? Okay, so what we did was that we did a systematic literature review. We had these search queries, and we had like maybe 5 to 10 different digital sources, and we adopted this standard methodology that first we filtered the papers based on the title, which gave us 56 papers from all the sources together. And then we screened the papers based on the abstract, which further reduced them to 29 papers. And then we actually read the papers and just filtered out some more papers. So finally we were left with 17 papers which are relevant to our problem. Okay, so these are some of the sources that we used. You can see that IEEE on title screening is giving the most results, followed by Springer, ACM, Taylor and Francis, and Google Scholar, which is the normal case in most cases. Okay, and after the abstract screening, again, IEEE is the winner along with Springer and ACM. And after the content screening, so these are the 17 papers. So 17 papers are mostly from these sources: Springer, IEEE, Google Scholar, elsewhere, Archive, and CM. So these are the results of the screening bar charts. And regarding the concept drift, work has been continuing since the last like 15-20 years, but it has picked up like in 2011, and it went down for some reason. It went down in 2014-15, but ever since then it is on the rise. And even in 2020, you can say the bar is somewhere here, because it went down because we stopped the review in March. So, but this last descent is not true. So it is on the rise since 2015. People are researching on this domain quite a lot. And I don't know how much time I have left. No one.
Yeah, you have 10 more minutes.
10 more minutes. Okay, I need to hurry up. So in the papers, we find out that mostly people have dealt with the supervised scenario, but I told you that supervised scenario is not applicable in the industry because the data that is coming today is not labeled. So only 3% papers are dealing with unsupervised scenario, but we focused on mostly on these 3% and 12%. So these are the 17 papers that we categorize in a table, and you can see that barring a few top three, most of them are dealing with the unlabeled data which we selected specifically. These are the contribution levels. This is on our own. We developed a rating mechanism based on the fact that whether the paper has done thorough experimentation, whether the approach is globally acceptable, whether a formal framework has been proposed or not. So based on that, we assigned a good average or a below average label, you can say. So what I want to stress is that these three techniques at the beginning is DDM is the first technique for concept drift. That is the drift detection method. It's a supervised method. Uh, it simply says that, okay, you put your data in the algorithm, and if the performance goes down for quite a lot of time, and then you can conclude that a drift has occurred, and then you can retrain the model. EDDM means early drift detection method, and it simply says that, okay, I just find out the distance between two errors to understand whether a drift has occurred or not. And HLFR is basically the hierarchical linear four rate algorithm. And in this case, what we're doing is that we are first in the first level of hierarchy, we are detecting the drift. And in the second level of hierarchy, we are validating whether the drift has actually occurred or not. So these three algorithms are for the labeled part, and they have shown very good performance over different types of drifts from time to time. All the other algorithms like the committee of decision trees and this sorry about that, EFDD, MD3, CS minor, ensemble learning, RBMs, which are the sorry about that.
Uh,
All of these are actually on the unlabeled data. So these are the all the 17 papers, and the famous algorithms that have been summed up in the last 5 years of the research are these three: CDC, EFDD, MD3, CS minor, ensemble learning, RBMs, PSCCD, MD3, Sun. So now how they're different from each other, that's the main thing. So basically, uh, all of them are basically using the concept of a probability distribution. So what they're doing is that they are looking at the input data, and they already have looked at the training data. So they had the training data, they got the distribution of the data from that training data. The data that is coming today in the industry, we check the distribution of that data. For checking the distribution, we have many different approaches. We can use pure statistical approaches. We can also use deep learning. Deep learning is a field that has not been experimented uh, a lot in these domains. We just have one paper in 2017 which went with RBMs, but deep learning has not been explored in thorough detail. Even with autoencoders, if we just had one paper, which is not written here because it is not directly concerned with the topic of this thesis. But deep learning needs to be more explored more. These algorithms, what they're doing is that they're simply measuring the distribution of the data and comparing the distribution of the current data with the distribution of the trained data. And if the distribution is changing, there is a significant difference between the distributions, two distributions at different timestamps, then that is an indication of a drift. So basically, that's what they're doing. And you can see that the performance here, we have labeled it as good, 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 average, average. So it's okay. The performance is not very bad. It's a good performance as compared to the supervised scenario, but the supervised scenario is more robust because you have the labels. So these guys have experimented more. There are more research papers, and they have caught up with different types, all the different types of the drift that can occur. But unfortunately, the unlabeled, we don't have that much flexibility. So we have, in my opinion, we still have not been able to cater for all types of drifts in the unlabeled data scenario. And the other problem is that we don't have the data sets. So people have created their own data sets with the drift there and then experimented with those, which does not really standardize the things. So these are some of the problems that are there. As I don't have much time, so I want to finish this. Um, these are the findings. The ensemble means that the collection of algorithms together are basically making a prediction. So in this committee of decision trees, that's also an ensemble algorithm, and that's what they do basically. So that is more being used quite a lot. Retraining of a model is being discouraged. So they want you don't retrain all the time, because initially what people used to do, that they did not detect the drift, but they simply retrained the model from time to time. That is not a good solution. You only retrain when you detect the drift. So that is being discouraged, that you don't continuously retrain. There are not many unsupervised drift identification approaches, so we need to work on that. um, the results are satisfactory with respect to the supervised scenario, but we still need to do a lot of work to detect the different types of drifts in a very comprehensive way. There's no paper which does a comprehensive analysis across all the drifts for unsupervised scenario. And there are the review, some of them are review papers. For example, this one is a review paper where you see the dash, that's a review paper, but there are no systematic literature reviews as yet in this domain. So these are some of the findings. These are the data sets that the people have created themselves. These are the artificial data sets which contain different types of drifts. And these are the data sets which we found out from the from our survey, which contain the drifts, but it is not exactly specified when the drift is occurring. It is only written that these data sets contain the drift. So we are facing a very big problem with respect to the data sets as well. Okay. So to answer the question, three algorithms from the supervised scenario have been proposed. In the unsupervised scenario, we have a host of algorithms and they have given a good performance, but there has not been extensive experimentation as yet. There is even no systematic literature review. How to catch the concept drift? The basic concept is the same in that we catch the drift based on comparing the probability distributions. And for that, I have many different types of metrics and approaches, and I can develop my own approaches as well. It's a very interesting field in which one can work. So the performance is currently good, but it's not very thorough. It's not very thorough, and therefore this is the reason that the industry is basically not able to cater for this concept rate, because things are not standardized as yet for the unsupervised scenario. So the conclusion of my talk is that we need to absolutely explore this domain further, and one of the ways we can do that, one of my PhD students is working exactly on that, is that we use an autoencoder to actually detect the drift, and we have already one paper which has done that. In fact, we have two papers which have done that, so we have a proof that it is possible. But those two papers are extremely basic, and there is no thorough experimentation. So that's my talk. So if you have any questions, I'll be happy to answer them.
Uh, Assalamualaikum, Dr. Tariq. I'm a data engineer in a software company, and actually, our company aggregate data from different sources and then provide different type of process on it. Mike, the session you provided, that is very important for us because in so many areas we are using machine learning for processing of data, like classifying and identifying uh, or raw text or review text, and tagging for the different brand of products. I hope you can understand this.
Yeah,
So
yeah.
yeah, my question is that most of the time, while we are working on a different company, we are unable to approach people like you because we are not the part of the academic research, but basically these type of research are also very good for us. So is there any way that if we need to consult or seek help in certain type of things that is not related to the research, academic research I means, but it's not part of our work, so can we approach to you? Is there
Um,
any type of
yes, IBA allows teachers to provide consultancies. So it is possible to approach. We have other teachers as well. So you can send me an email. My email is written here. So when you give us a problem, then I will have to talk with my chairperson, Dr. Sajad Haider, to take permission, and then I can offer help in this regard. Yes, it is possible to do it, and it is also possible that we can get some student to work on to do some sort of experimentation. So we already are in collaboration with AKU. We had 3 or 4 meetings with them, and we are working on two to three projects with them already. So you can send me an email here at tmehmood@iba.edu.pk, and we can make it more official.
Okay, fine. Other than that, if you have discussion, need to further discuss or further uh, reviewing your things, so is there any possibility I could email you and share something with you or
Yeah,
get?
yeah, sure, sure. It's not a problem. If you want to talk informally, it's not an issue. You can just email me and we can have a discussion over that. I'll provide my input when I get the time. I'll definitely just reply to the email. It's
Okay,
not an
thank you
issue.
so much.
Yeah.
Okay, audience, any other question? Okay, thank you, Dr. Tariq
Thank
Mehmood,
you.
for the talk.
Thank you, Dr. Noman, for this initiative. I really appreciate that.
Thank you very much. Okay, let's move to the next talk, which is by Dr. Zeeshan Ahmed from Net Plus IT Solutions Canada. And the topic that he's going to discuss is deep learning driven network design and management. So I would request Dr. Zeeshan Ahmed to please take the mic and talk about this speech. Thank you very much.
Many thanks, Dr. Noman. So it's almost midnight here in Canada, but it's morning time in Pakistan. So good morning to all. Let me first share my screen with you. Okay.
You will have the present now option at the bottom.
Yes, I do have.
Thank you.
So let me share my entire screen. So can you see my screen?
Yes, yes.
Okay, let me see. Okay. Okay. So I'm delighted to be here to talk about how we can achieve human level intelligence and what is being offered by current deep learning architectures and what is missing. Mm, as these days, I am involved in developing a lot of computer networking products. So my initial plan was to talk about applications of deep learning in computer networks. But then I realized that not all people would have that background and nor everyone will be interested in networks. So I changed my mind and decided to talk about a fairly general topic, that is human level intelligence. And I was preparing these slides for one of my upcoming talks next month. So I thought that it's a great idea to share this information with you, and why not get your feedback? So let's get started. Uh, there is an assumption that our intelligence is governed by some simple principles, and if we could understand those principles, then we'll be better able to explain our intelligence and incorporate in our machine learning models. Most of these principles deal with the notion of learning. That is, most of the intelligence we acquire is not simply magic or pre-programmed in our brains, but instead we learn it through experience, observation, and exploration. So naturally, the question arises: what is meant by learning? And we can define learning simply as a lasting change in behavior that is caused by an observation or experience. So in the context of learning, the hypothesis of intelligence become very interesting, as it allows us to build more compact yet powerful machines that have the capability to understand, reason, and plan according to the conditions of the environment. And deep learning provides us exciting opportunities to design such an intelligent system. If we have to summarize different deep learning architectures, we can do so by using three concepts. And these are fairly basic concepts. That is the objective function, neural network architecture, and the training or the optimization process. So these are essentially the building blocks of any neural network architecture, be it CNN, RNN, or LSTM. Let's further try to explore this idea of deep learning. Let me. Of course, in this slide, I would be able to provide a very basic introduction about the deep learning, but it is my assumption that all of you already know these very basic concepts. So in a layman's terms, a deep learning model tries to mimic our brains in processing data to accomplish tasks like speech recognition, language translation, computer vision, and so on. And there are some very interesting concepts attached to deep learning that are necessary to simulate intelligent behavior, such as distributed representation, hierarchical level of abstractions, and architectures with considerably different characteristics, and also a variety of optimization techniques. We'll talk about these and some other concepts in more detail in later part of this presentation. Deep neural networks comes from neuroscience. We all know that, and are heavily inspired by the working and architectures of our brains. For example, the idea of distributed representation and decision making by patterns of activations from millions or possibly billions of neurons at a time is something that that has been inspired from our brains. The idea of spikes, the idea of non-linearity, such as using sigmoid function or ReLU, the use of convolutional networks, all comes from the neuroscience. And this slide is very important, as all the concept that you see on this slide has inspired one or more fields, or you can say branches in deep learning. I will talk about most of these concepts in some detail in subsequent slides. There is a long way to go and achieve human level intelligence, and there are so many things about the brain and cognition that we really don't understand or even don't know at this point of time. One important and very important characteristic of neural network is that they have multiple levels of representation, ranging from low-level details that can be used to better understand the working of our brains to very high-level concepts such as cognition, language, consciousness, attention, and memory. Before we can talk about cognition, it is very important to understand the current state of deep learning. We have made a tremendous progress in some areas of artificial intelligence, such as natural language processing, speech recognition, computer vision, and so on. But still, there are so many areas where our models are far from human level intelligence. They have some major limitation, and there are some concepts that are missing from our models. Those concepts are either the one we don't know how to formalize in a mathematical way, or we haven't discovered them yet at all. We simply don't know that those concepts exist. Sample complexity is one of the major limitations. That the limitation is that our models needs a lot of examples to learn a very simple concept. Humans have a very good understanding of their world and very good representation of the environment around them, and therefore they are able to understand new concept with even just one example. So you just look at a flower, and you can immediately recognize that, oh, it's a flower. And if you have only seen rose flowers in your life, and I present you with the let's suppose a lily or a tulip, you will immediately recognize that, even though that was not part of your training set. So we need to see how our models can generalize with few examples by utilizing the knowledge of the world. Another important aspect is human dependency, because our models require human level data to make their decisions. When we label objects of interest, it's essentially the human knowledge and biases transferred to our models. While we see that the kids can learn many concepts of their own by simply interacting with their environment and observing what's happening around them, but even the most sophisticated model can't do that. Another interesting fact is that these models can be easily fooled by adversarial example. You might have heard of an adversarial network, especially designed for this purpose. And in those cases, the mistakes these models make are quite different from the mistakes humans do. And often it is impossible to identify that why the model acted in a particular way and did that mistake. So what are the missing elements? We need to identify the elements that are missing from the puzzle, and some of the possible ways to approach human level artificial intelligence and overcome these limitations. And again, so some of these concepts are very basic concepts, like generalize with smaller data set or generalize on multiple data sets. But some of the concepts are really complicated, such as the detection of causality, or how to formalize consciousness. We are going to talk more about that. So let's start with the sample complexity, that is the ability to generalize from few examples. And another important capability of human is to generalize in an out of distribution way. That is, the data that doesn't look like the training data, they are even able to generalize, as I already given you the example of identifying a new type of flower. Humans can easily understand and adapt if they encounter an unknown object that doesn't overlap with the training distribution. But how could possibly our models can generalize in a similar fashion? We can generalize with even one example, because we have a very sophisticated model of our world, and combine the missing pieces of information in a systematic way to arrive at a conclusion, what we call the systematic generalization. This is very important in real world application, for example, in autonomous driving vehicles, where it is almost impossible to collect data about accidents without exposing the vehicles to dangerous situations. Now, on the other hand, human can learn to drive even though they are never exposed to those dangerous situations. That is because of something we call system 2 cognition, the ability to reason, the ability to consciously construct hypothetical scenarios and future possibilities. And it is somehow connected to the concept of causality, and unfortunately, our models are not very good at that. It's interesting because it's fundamentally more than just capturing the structure of the data distribution. Our models are not good at determining that if an event happens, what will be the effect on other things without doing the learning process again. And another important missing thing is common sense. And common sense is not so common. And that is especially true for our models. Common sense means that the humans know how the real world works to understand in a particular way and act in an intelligent fashion. But that information is very difficult to explain and formalize, and is not available to machines. So you can see that there are so many missing pieces of the puzzle, and that we somehow need to find, identify, and formalize if we want to achieve human level intelligence. The initial goal of the deep learning was the ability to train multiple levels of representation, where the higher levels would correspond to more abstract aspect of the world. That is, it connects with the underlying explanation for how the world works, for data that we are analyzing. And these high level abstract things tend to be what we communicate with language. We don't have that yet with deep learning, and we are actually far away with the level of knowledge human can reason and communicate with the language. So for that, to achieve that, we need to build a very good representation of our environment. And one of the keys to do so is called discovering disentangled representation. That is to separate the high-level factors from the raw data in order to do what we to put more constraints or more priors on what the representation should be. We need to say something about the kind of representation, and there are many priors that we could use. Most researchers in the field of design entangling representation focus on the idea that higher level variables are independent of each other, but that might not be true in all the cases. We could have dependencies between the factors, but they are somewhat simple and might not be statistical in nature. And also the high level factors tend to be related to agency and causality. So many of the real world ideas that we have correspond to the aspects of the world that can be either the cause or an effect of something, or we can say how one cause influence and effect, which has to do with how agents like humans influence the world through their actions. Another important notion is that of affordance. And it is a subject of studies for century in psychology. And the idea is that that we think about objects in the world is not really about their physical characteristics, but more about how we interact with that object. So we are stating this idea to define objective functions for unsupervised learning of agents that encourages the representation of the world to be broken down into dimensions corresponding to the aspects of the world which the agents can control. And this principle states that when we can control some aspects of the environment, we should have a very well defined quantity in our mind corresponding to that aspect. So the agent can make a sequence or policy of action which can specifically target a particular aspect of the world. And that is something we are still trying to find the most efficient way to express this idea as a mathematical formalism. Wow, attention. Attention, please. Attention is the core concept that is going to unleash our ability to extend our model to next level of cognition. Very, very important concept. And a lot of research has already been done and is going on this topic. Attention is simply the fact that computation is going to be focused on a few elements at a time. And then iteratively, we are going to focus on two different elements as our attention flows from one thing to another thing. Attention is not necessarily on the outside, but a lot of what matters for attention is inside. In other words, of all the thinking, perceptions, and emotions that might be present in our mind, we are really focusing on one or two at a particular moment. So attention is focusing on one or few things at a time. And it turns out that it really makes a big difference in many natural language processing tasks. And we have discovered that if we introduce a form of attention in recurrent neural network, there is an improvement in tasks such as machine translation. And around 2014, we discovered a way to train a mechanism with attention by using an idea called soft attention. You can think of it as attention computed on every possible element in a set, and we get continuous quantities or scores. Then we can compute gradient through these computations, and we can compute how if we had put a little bit more attention on a particular element, how things would have been better. So we don't need to tell the machine where to focus. It just computes some weights and which output a score for every possible element and tell the machine learning model where to focus. Another very important aspect of neuroscience is memory. Something that people have started to incorporate in neural nets and what we call those network as memory extended neural networks. One of the first such architecture is a neural Turing machine. The concept of memory is something that we haven't yet figured out completely, and we have actually made more progress on the attention than on memory, but it's clearly something that we use and that is very important. Humans have many different kind of memories. We know that some part of our brain stores episodic memory so that the actual things we do in our daily lives are stored there. But we haven't really found a satisfying way to incorporate this sort of knowledge, is this sort of mechanism in our neural networks. However, interestingly, it's also connected to attention somehow. So people will use some sort of scoring like mechanism to decide which part of the memory we should access or write at a particular time in a given scenario. And let's talk about a very important, but you can say slightly complicated concept, that is of system 1 and system 2 cognition. System 1 is what we call fast or unconscious memory, while system 2 is what we call slow or conscious memory. The unconscious cognition are the things you can do very, very quickly, the things that are automatic, like walking in your home. While system 2 is all the things that are conscious, we have to think about those things, the things that we can verbalize, that things we can explain, like programming in Java. As a human, we have access to system 2 knowledge. We can explain this type of knowledge very well. But the unconscious knowledge, the system 1 knowledge, even we don't have access to that knowledge. So we cannot really communicate that information. Interestingly, current deep learning is good at system 1 cognition. While normal programming, if we talk, or human, we are good at system. Well, human utilizes both system 1 and system 2. In the old days of artificial intelligence, what the researchers were trying to do, they were actually trying to achieve system 2 things like reasoning, logic, planning, and so on. But it requires expensive computation, huge amount of computation. For example, if we think about how the machines play the game of chess, it's like exploring millions of paths before making a move. But we humans combine system 1 and system 2 knowledge, and if we play chess, we don't need to go through millions of move to decide what should be the next move, what should we play. That is something we know to learn how. That is something we should know how to learn and how to implement on our machine. But unfortunately, we don't have the right answer at this time. Consciousness is very mysterious, and it's really the time for the deep learning community to try to formalize this concept. It's about different kind of functionalities in our brain that we should be able to decompose, understand, and then have machines to be able to do that in a particular way. But the big question is, can we formalize consciousness? Is it possible? We have talked a lot about attention, and this may be the most important aspect of consciousness, the ability that we have to sequentially focus on different elements and attend just the right things what we have in our mind at the particular moment, and that's what we call access consciousness. And I will just focus on access consciousness for the time being. And the things that we are thinking about and that we have selected with attention become like dominant in our mind, and everything in our brain is then conditioned by that. So we need to explore more about it. It's a very powerful concept. We need to explore more about it. Consciousness is very tightly coupled to language. Since animals that do not speak still have consciousness, therefore we can argue that language is built on top of consciousness. How we can build machines that can understand language? We have machines that can be trained on huge quantities of text and it still makes really simple semantic mistakes. So what is missing is that in order to understand natural language, our models should have a very good representation of the world, a very good model to represent the realities in the environment. So few researchers have looking at something called grounded language learning, where you just do not learn from text, but you jointly learn from text and what it is referring to. And one such attempt is Baby AI platform, where an agent tries to interact with a limited view of its environment and tries to achieve um, uh, goals that are communicated to that agent using natural language. I would highly recommend all of you, if you are interested, to please learn more about Baby AI platform. The link is given at the end of this presentation. So this is a kind of investigation that we need to do more in order to build natural language understanding system, which have an internal representation of the word of what the language refers to. Another interesting thing is the ability that we have to reuse the pieces, like the words and the phrases, in completely novel ways. That is the ability of humans to generalize on new combination. So it is a form of compositionality. And it's a very basic notion. And yet it's a central notion to understand why machine learning can or cannot generalize. It has been shown that deep nets enjoy some forms of compositionality, which explain why having deeper network can generalize better than shallow networks, and why having these distributed representation where each layer you have multiple features that somehow jointly represent a pattern. And that actually enables the ability to generalize to new combination of the features that correspond to the pattern that model might not have seen before. And that's something very difficult or almost impossible to achieve with shallow networks. But humans use a different type of compositionality that we don't get from neural networks. So what is that? Let's learn more about it. Let's discuss that more. For humans compose new ideas on the fly. So in a normal neural network, the computation is fixed after you have trained each layer, and it just sends its output to the next layer, and it's always the same. It remains the fix. Whereas if you think about attention mechanisms, it allows us to decide on the runtime which concept to focus on and what should be the next thought. So this form of composition that is dynamic isn't something that we have right now in our model. And it helps us generalize beyond the training distribution. For that, we need to be able to decompose our knowledge into pieces that can be recombined on the fly. And this is a requirement of this sort of dynamic computation to happen. This is really a requirement. The next topic we are going to talk about is causality. Causality is one of the greatest strengths of high-level cognition. We want high-level variables to be able to recombine in new ways and operate in new fashion, in novel ways, and many of these correspond to causal relationships. This type of relationship is very difficult to show at the low level. At the level of neurons and synapses, it's very difficult, but we can show it for high level concepts like the objects of the real world. And that is again something the community, the research community, have just started to incorporate in machine learning and deep learning, but we are really in the early stages, you can say. The big question is how to discover these causal variables. We need to learn a representation from low-level data Let's suppose if we are analyzing an image, the low level data is real, the pixels. To the right, high level space, where these variables become cause or effect of each other. And for discovering such a representation, we have been exploiting hypotheses that the reason for the change in the world are the changes in the distribution. And that is due to the action, also known as the interventions of agents like human. An agent cannot control everything in the world, but maybe one or few aspects at a time. If I were to represent information in the right way, where one of the dimensions of that space is changing, then the resulting change in the distribution will be localized. And that is something we want to achieve. It's not like that a simple change completely change the distribution and now we need to retrain our model. So we strongly need a representation that is more robust to these changes, and that could only be achieved by localizing the effect of any change. But we don't have the right distribution, so how do we get there? And that is something we currently really don't know. We have discussed so many concepts that is almost impossible to digest, but in summary, we can say that it's not enough to train our model on a single task and be able to generalize. If we want to make serious progress at human level artificial intelligence, at some point we need to build models that understand our world at the same levels as human. Right now, it would be difficult to do in the real world environment, but we might be able to do it in specialized.
Assalamu alaikum and very good afternoon here in Malaysia and good morning in Pakistan. Okay, the topic which I have chosen today is very important because since many years we are talking about Industrial Revolution 4 or IA 4.0, and we are seeing basically we have been suggested to work on it by the industries and by the research community, but practically this how much it is possible, this what we have to see. So the intention of my talk is to actualize the issues associated with industrial internet of thing, and what kind of machine learning will be appropriate for that. Okay, I just introduce myself. My name is Sayyid Muslim Jameel, and I'm a researcher at Computer Information Sciences Department, High Performance Cloud Computing Center, University Technology, Petronas, Malaysia. So the outline we will cover that are we ready for the Industrial Revolution 4.0. I will also the intention of my talk is to realize that okay, what are the need of IR 4.0 and where we stay, where we stand for that, and what changes we need to make to progress in this direction. The secondly, basically, I also worked something in my research, so I'll discuss about my proposed framework which I have developed. And I did not only propose my framework, but I materialized my fundamental findings towards the prototype development, and I developed a prototype for that. And I'll also discuss the issues which I faced during the prototype development and fundamental findings. Basically, mainly we do fundamental findings, but when we go towards this practical implications, so a lot of challenges we faces. Theoretically, we might ignore them, but when we go towards the practical implication or implementation, we faces a lot of issues. So I would like to highlight those some. So what is Industrial Revolution 4.0? Are we ready? I'll just go through very quickly. Basically, we have seen that the industrial revolution has been evolved, different century to century. And today, when we talk about IR 4.0, it is something related to internet intelligent production or incorporated with IoT environment or big data analysis. So actually, these are some pillars for the Industrial Revolution 4.0, in which we can see that IoT platform and mobile devices, cloud computing, augmented reality, big data analysis, and so on. So these are the defined 9 pillars. So this is some potential impact that this is a very old report, so I'll go. So it has been discussed that till the 2025, the potential value of industrial IoT or IR 4.0 can be reached to a $3.7 trillion. But I am sure that after COVID-19, this will increase, because nowadays people are more going towards the industry automation and working from home, or they are more making devices to be uh, to be used in the industries, using the AI and big data and all this stuff on IoT. So now there are some implications on the industries, on the academician, and on the researcher. So for being industrial, we need to leverage the technologies. For example, I'm not talking, basically, if we talk about the Pakistan, so how many industries in Pakistan are welcoming or are going to get benefit from the IR 4.0? So this what have to be educate the industry that this is very essential for them for the long run to compete the upcoming market. So they need to be improve their infrastructure. Uh, they should leverage the technologies, new technologies, improve their infrastructure. They must upgrade their workforce by providing trainings and all this stuff, and they should promote the advanced education. So there is also some implication on academia, that when we see about the academia, we see the very very big difference between the industry and the curriculum which we teach in our universities. So that gap should be minimized. I can understand it could not be filled, but it should be minimized as much as possible. There should be some liaisons between the industry and academy, and there should be some special courses which should highlight the current industrial demands, not specifically to the Pakistan, but globally. And if you will see that current industrial demand for globally is the technology implementing the IR 4.0. Also, our research community should optimize the existing algorithm, as Dr. Tariq Mehmood discussed, the issue of concept drift, and that because the traditional machine learning approaches are not applicable or become obsolete when we talk about streaming analysis. The new method needs to be produced in order to resolve the issues by IR 4.0. Also, when we talk about IoT, Internet of Thing, and data analysis, all this stuff, there is a big issue of security or privacy. So this area should also be addressed by the research community, and people are doing work on it. As a and Another thing is improve the legacy framework and business processes. When we talk about industrial IoT, so all the processes are going to be done by the machines, and different policies, different policies need to be introduced to, or new business processes need to be investigated to have more better execution of the business. So let's discuss what is industrial Internet of Thing in a bit more detail. When we see that industrial Internet of Thing is a network of intelligent, highly connected industrial components that are deployed to achieve high production rate with reduced operational costs through real-time monitoring, efficient management, and controlling industrial processes, asset, and operation time. So mainly, if we will see that there are four major parts of IIoT. When one is the devices which are responsible to capture the data, or which is basically performing the operations. Another thing is connectivity. That connectivity, like the medium, which is responsible to transmitting the data, and efficient transmission is very essential when we talk about IIoT. Then third point is itself a data storage, because we know that in IIoT environment, the work is done in the the different systems are automatized to perform or perform the business process. So their intelligence will always be come from the data storage. So there should be sufficient mechanism to store the data. And last but not least, which is the automation, mostly using the machine learning or deep learning, as we have discussed. In my research, I mainly focused on the machine learning part, and I have proposed my own model for that. So these are some applications areas. If we talk about IIoT, it is not about industry like manufacturing industry, but if we'll see that smart grid, smart car, smart city, smart communication, even in health area, or in Malaysia, we are working on oil and gas also. So because I am associated with Petronas, so we work on the oil and gas. So we analyze the different wells and seismic data and all this stuff. So its practical implications are a lot. So significant, okay, what is online machine learning? As it has been discussed by Dr. Tariq Mehmood, the issue of concept drift. Luckily, I did my PhD in the issue of concept drift. So, and it was very interesting to see his contribution. So we know that in the machine learning there are two kind of machine learning. One is offline machine learning, and another is online machine learning. So in offline machine learning, all data ingest at time, and there is no chances that the machine learning model will observe any changes. However, in the online machine learning, that the machine learning model is connected to the streams, and there is possibility that the data coming from the stream is not that the same on which the machine learning model trained. So in that situation, the model will become obsolete, or it will decrease its classification or whatever prediction accuracy. This phenomenon is normally known as concept drift issue, and it is very hot issue to be resolved. So to understand the issue of concept drift, we can see that there is a machine learning model which has been trained on a historical data X, but when it has been deployed in the system, in IIoT environment, so the data which is coming from the different data sources, it could be heterogeneous data sources, it could be sensors, whatever. So there is possibility that the data itself can change, its feature for class distribution. So as Dr. Tariq would discuss about the class distribution changes, So they are another type which is called as virtual concept drift, in which the class distribution of the model does not changes, but internal feature of the data itself changes. So when the internal feature changes, for the deployed model, it is also difficult to understand, and in the literature it is known as the virtual concept drift. So the machine learning model will not properly predict it, and will definitely degrade its classification accuracy. This phenomena will highly likely to be introduced in the IR 4.0 or IIoT environment, because one of the mechanism to resolve this issue is to just retraining, which Dr. Uh, Tariq highlighted, that it is not feasible solution, because when we talk about the IIoT environment, again and again retraining is not a feasible issue, and it is not recommended. So our system should be adept enough to not only detect the changes, but to make the necessary changes in itself. So this is very important. So one more thing, what are the challenges? Because I have investigated it thoroughly, so I have seen that there is one more generic framework for the multiple type of drift is not available, and it is not it is very difficult. I will not say that it is not possible, but it is very difficult to come up with a generic framework which could handle all kinds of drift, as sudden drift, gradual drift, recurrent drift. There are many kind of drifts, as has been discussed in the keynote speech. So one more the issue is to handling the high dimensional streams, because most of the literature we have seen, they worked on the low dimensional stream, like they are working on text data, or they are working on the data coming from 1D data, which is coming from the different sensors. But there is also possibility when we talk about computer vision. So in the computer vision also, the model will analyze data from the different streams. And one other thing, heterogeneous data sources, that for example one data source producing 1D data, another data source producing the imagery data. So there are very complications when we talk about the IIoT environment in some scenarios, not in every scenario, but in some scenarios. Another thing, that detection of the concept drift versus the noise is also very challenging. So the solution is only the adaptability and online training, because as it has been discussed in the keynote, that it is very challenging to work it on unsupervised manner, and it is not recommended to retrain the model again and again. But most of they should be most of the literature who even adapt the concept drift, but they applied the offline training, which is not suitable, because when you adapt anything for the training purpose, if we are using offline training, that is not advisable, because in the real scenario there should be a mechanism of online training where the model should continuously, without the human intervention, it should not only detect the issue or concept drift, it also should adapt it. So these are concept recurrent, and all this are very important. So I mainly focus on the image classification task, because the issue, the research objective I did basically to identify the type of concept drift. When we talk about the 1D of concept drift, so the type also have the type of data streams also has the impact on the type of concept drift. For example, in my finding, I have found a new kind of concept drift when I was dealing with the multispectral image classification. So it was very important to deeply understand to identify the type of concept drift in high dimensional data streams, which can adversely affect the accuracy during the online classification task. The next objective was to propose a novel framework to adapt concept drift and retain classification accuracy at an acceptable level during online multispectral image classification. I focus on online and color imagery actually, and later I did improve my existing framework. Uh, I wanted to make it a bit generic. That's why I improved my the previous framework to adapt the concept drift in color imagery. So my this was the identification of concept drift. For example, this is the image classification model which has been deployed in the system, and these are the data sources. Which is initially these three data sources is connected with the system. This is satellite one, satellite two, and satellite three. For example, these data sources containing some particularly feature like these three sources contain RGB images, RGB data. And we know in multispectral we have multiple spectral like near infrared, short infrared, up to 3 to 10, 15 it is recognizes. So let's suppose if a new satellite becomes a part of the deployed model with advanced feature like near infrared. So our model will not able to detect the changes, and it will not sufficient to incorporate or recognize these changes. So it will basically it will become obsolete, or it will become less accurate. So other two things I did that when a novel class arrives. For example, a machine learning model has been trained on a particular classes like Y1, Y2, and YC. But after some time, a new classes like YC plus one is been introduced. But my model is not able to know the latest model. So it latest class, new classes. So it will definitely not recognize it, and its classification accuracy will be drastically decreased. Another thing was new sample arrival in existing classes. For example, there are Y1, Y2 classes with sample x1 till xn. But after some time, xm plus one, a new kind of sample arrives with some advanced feature. Okay, so that feature changes will make cause the accuracy degradation. So in the color images, I highlighted two type of concept drift, and in multispectral, I highlighted new spectral band. I introduced the new spectral band adaptation issue. These were already discussed in the literature, so I did not identify these type of concept drift. I identified the new spectral band adaptation issue. So this was my proposed framework. I used the I have developed and optimized convolutional neural network, and it is and mostly the adaptation in the literature is being achieved through the ensemble. So ensemble is considered one of the famous ways. So I also adapt the same mechanism for the adaptation process, but it is dynamically increase and decrease once the new channel arrives. And my this is the training module which detects the new spectral band and train a new instance, and then add that new instance into the dynamic ensemble classifier module. So this the finding of my this objective was published in Q1 journal. Later, I improved my previous framework, and I have introduced online classifier update mechanism to incorporate, to update my model with the existing classes. And I have proposed the online training module through which even though there is a issue of labeling, and I resolved that issue of labeling in my online training module. I basically, if any new class arrives but it is deployed in an environment where where this model will not receive the label of that particular class, so how my model will resolve that issue? So I have developed algorithm and successfully did it. But what it does, whenever my model recognize by identifying the error rate, if new class arrives, it send it to a folder, and in the folder I applied the k-mean clustering approach using the Silhouette method and Euclidean distance, through which I identified the similarity boundary of the similar classes. So, and I hypothesized them the different hypothetical class name like x1, x2, and x3, and I trained my model with that hypothetical class's name. Later, which could be which will require the human intervention, and it will be update, like x1 is equal to maybe elephant, or x2 is equal to maybe any other new class. It needs a minimal human intervention at this level, because it was challenging that how we can resolve the issue of labeling the class, because this problem is for the supervised learning, and the findings are also published in the Q1 journal. So these were some analysis result. I initially performed many results to see that what is the impact of the different available models when we before and after concept drift. So let's suppose it's the extensive learning machine model when we have produced 92.12, and after drift it reduces this classification accuracy very badly. So the data set I used here MNIST, and with an additional feature HOG to simulate the virtual concept drift scenario. For multispectral, I have prepared my own data set. Basically, this was the initial data set which was available in the Kaggle, and its image size was 350 into 350 by 10, which with 317 samples, but its accuracy was only 20%, and because of noise and less data. So I produced my extended multispectral data set with the same features, but I applied the image augmentation process to increase the sample size. One of the characteristic of this data that it is not like in multispectral, it has 10 channels, 0 to 9. But also because to simulate the concept drift, I have designed a pipeline through which I can on and off the different channels to simulate the new spectral band issue. Okay, then I tested my model when I supplied 3 channels. Then accuracy was okay, but if you will see that 56.70, it is due to the noisy data available in the channel 1. Similarly, I gave some additional 3 more channels, and I saw that okay, accuracy is very much reasonable. Then I applied, gave my system to more 4 channels, and accuracy was okay. So my model was able to adapt the process. My DEC model was working better. Then I also checked my ensemble performances of all the cases, case 1, case 2, case 3. I have seen that not noticeable improvement in the case 3 when I have the maximum number of instances in my ensemble classifier with 96.61. So later I did some, I use CFAR and skin disease data set. This is very challenging data set. I wanted to test my model on not only benchmark data set, which is CFAR 10, but on the challenging data set. This is the ISIC 2019 Kaggle challenge dataset. If you will see, there are around 9 classes, 8 are mentioned here, and this is highly imbalanced. So, and its features are very similar. Like, if this is class 8, which is unknown, its features are very similar to the class 0, which is melanoma. So this was very difficult for even a traditional or static machine learning using the basic training learning to properly classify these images. So I tried to validate my model using the benchmark as well as more challenging data set. I have prepared the pipeline that is very important to simulate the concept drift, as since till now we don't have the uh, image data set which contains the concept drift. So we simulate it by our own, as it already been discussed in the keynote speak. So I have tested my model when in the case C, when no class arrival, when the novel class arrives before adaptation, and when the novel class arrives after adaptation. So we can see the significant difference between the before adaptation and after adaptation. I have developed two different models, model 1 CF10 for the CFAR10 dataset, and model 2 SD for the for the skin disease. You will find that you will find that these are the confusion metrics after adaptation. So after adaptation, this is the confusion metric for model CF10. So it is okay. Its performance is good. Though I want to make it like above 90, 94, 95%. It is 89. But when we talk about the skin disease data, this data, as I told you, that there is a problem of class imbalance. That what I wanted to check. So due to class imbalance, it is highly biased. You can see this confusion matrix. This model is highly biased towards a particularly imbalanced class, which is class 1, NV. This class 0 is class 1 is envy. So this, because the most of the samples were from the class 1, and it is highly biased. So these are some loss measures. Then I tested my proposed framework with other ensemble CNN, ensemble support vector machine, and random forest. So before classification accuracy, the best accuracy we found from the random forest, which is cellular learning model 96.84. But if you will see, after adaptation, all these models badly performed, and our proposed model, was able to just maintain its classification accuracy. And these are the some figures of loss and F1 score. So these are some confusion metrics of all the four models which I compared. So these are my contributions. I think so. These has been discussed in my paper. So if we need to go into detail, you may refer my papers for that. So further improvement. This is very important for those who are willing to pursue their PhD or master studies in this area. Feature extraction process need to be improved, distinguish between a similar feature. If we have seen, I identified when I was just performing, because I have produced a online training mechanism in which an unsupervised approach is responsible for identifying the different class boundaries for online training mechanism. But my proposed framework was not for the benchmark. It worked well, but for the challenging data set, where the similar features are very similar, so it need to be improved. Uh, because it was difficult for my method to distinguish between the similar features. So this is the one future direction. Improvement in ensemble approach is needed for hyperspectral images. As my model, as the number of instances increases, So it will also cause the memory and as well as the computational complexity. So it is recommended to improve the ensemble approach for hyperspectral images, because in hyperspectral images, number of channels are not 3 to 15. They could reach more than 200 or 150. So this is very important to work on it. Another thing that address the issue of joint problem, concept drift, and class imbalance. For example, if we will see here that because this data was highly imbalanced, like in the class NV, we can see that the number of samples are more than 12,000, and in the class 6, the number of samples are very comparatively less. So which causes the imbalance or overfitting issue in the model. So because I did not focus on the issue of imbalance, that's why I do not consider that issue. I focus on the concept issue. So the future studies can be done to resolve the joint problem of concept drift and class imbalance. So in the high dimensional data, because in the low dimensional data, this kind of work is being going on. One of my student also doing one of my student doing this research area, means issue in his PhD. So one other thing is generalization of the framework towards other type of concept drift. This is very important. For example, I try to generalize my framework, but when we talk about the different type of concept drift, so many characteristics varies. But I propose this could be done if we use metacognitive approach. Like there should be a different strategies which should dynamically updated for the different kind of concept drift. So a generalization is possible, but not easy. It is challenging task. So if someone want to work on it, okay. I did not only just completed my fundamental finding. I tried to mature my finding towards the prototype development. So I worked with Kongo University, South Korea, and USM University, Malaysia, and the Dermatology Department of Malaysia. So we actually propose a prototype of an artificial intelligence based solution for skin disease. So actually that approach I have implemented my model in the dermoscopy device, and this device is adaptive device, means it could be learn new thing, adaptive for new disease. System will improve its performance with time. So basically we have made two different module, one for the common user module. It will only suggest the patient to just visit the health practitioner and educate the patient about the importance of that particular skin disease. Another module was for the health practitioner, which will assist the practitioner to diagnose the type of severity of the skin disease and reduce its patient monitoring time. And we are currently working on it, and especially with the uh, help of South Korea University, Kongo University of South Korea. Kongo University helping us to develop the hardware. Okay, so skin disease detection, we basically I use federated machine learning in it, because we wanted to maintain the privacy of each user. So this is how it's very. So this is my model, and these are some steps which we have done, technical steps, and the validation was performed. Is the responsibility of the health practitioner. So this my research methodology, and it is about different phases, starting from requirement analysis. If we see that initial skin disease is for dermatology, we have to design study procedure and protocols according to the by ensuring all the ethical and privacy concern. So because it is a clinical type of study, so we need to take the permission from the government agencies and from the patient for their data to be used. Then data collection, data preparation, design and implementation, evaluation, validation. The prototype one has been done, and for the second prototype, our current state is data annotation preprocessing task. So, so some of the challenges for the deploy for prototype development is data privacy issue, like patient permission, government permission is very important. Data collection and annotation, continuous engage with health practitioner to acquire suitable data samples is very important, because for the clinical training testing we need the actual data, and the data collection will only be can only be performed by the health practitioner. They have their staff for that. So it was very difficult to be continuously engaged with them, because they are very busy, and it caused a lot of hindrance for us when due to COVID. Since one this issue this work slowed down a lot due to COVID, because the doctor will not have much time to give us and all this stuff, and we were also being 4 months of quarantine here. So this is the issue. Then patent filing, they are something related to very important, and it also needs some number of years. So develop appropriate commercialization strategies, because if we talk about to mature or to materialize the fundamental findings towards the prototype development, it is very important to also go for the commercialization of that. So there are basically different tiers, like one fundamental research, then applied research, then the research for the commercialization. And when we talk about the commercialization strategies, it involves the industries, beneficiaries, and a lot of large scale production and all this stuff. So we currently we are also highlighting some industry for this. So that was skin disease was one of the application of my proposed framework. My other these are two different projects for the load forecasting and for prediction of oil and gas. These are also using the my proposed framework. However, in these, because these are the time series, so instead of ensemble CNN, I will use LSTM and will use my own approach for concept of handling. So these are some my talk for today. If you have any query, you may contact me or you may ask.
Okay, audience, if you have any query, you can ask. Okay, I think there are no questions. So
Okay,
let's move
thank you very
to
much.
the next speech. Okay, the next speech is being given by me. I'm Professor Dr. Noman Islam, professor at Iqra University and also associated with University of Kuala Lumpur, Malaysia as postdoc research fellow. And the topic that I'm going to present is machine learning based approach for load balancing in cloud computing. Okay, I hope you can see my screen. Okay, so let's start the presentation with what is cloud computing. Cloud computing is the fourth utility uh, besides the water utility, sewerage utility, electricity utility. So similar to these types of utilities, computing can be regarded as a utility that can be used whenever needed, and we have the illusion of an infinite resource available, and they are provided via dynamic provisioning. So, like for example, water. We need water. We can use. We can just use the water as much as we need, and we pay for whatever we use. Similarly, computing can be used as a utility. So that's the basic idea. And there are various service models that can be used. For example, computing can be provided as an infrastructure, as a platform, or as a software. Then there are various deployment models of cloud, like public cloud, private cloud, hybrid cloud, and community cloud. So a public cloud is available to general public. Private cloud could be used for internal use by an organization, or there can be combination of private and public cloud, which are called hybrid clouds. And then a community can develop a cloud for themselves. In our research, we identified different challenges of cloud computing, which includes data protection, data retrieval, and availability. So, cloud should be available 24 by 7, and it should have the reliability of 99.99%. Then there are different administrative issues, regulatory issues, security, load balancing, fault tolerance, interoperability, and portability. Our focus in this presentation is on load balancing. So, what are the objectives of this research? What we are going to discuss today is to identify major challenges pertaining to load balancing in cloud computing. First, we will identify what are the major challenges in load balancing, and then what are the possible solutions, and can we develop a taxonomy to classify them? Then, how can we evaluate different load balancing solutions based on different matrices? And what are the future directions? Then in this research, we are going to propose a novel load balancing solution based on long short-term memory model. So we performed a systematic literature review, and we have published this research in a Q1 journal, Impact Factor journal. So the keywords that we used for search were cloud computing, load balancing, fault tolerance, machine learning, reinforcement learning, etc. And we considered around 100 papers. After the final selection, we performed different selection criteria, and we selected journal papers from some of the well-known publishers such as Springer, Index Science, IEEE, ACM, elsewhere, Taylor and Francis. And then further selection criteria was used. For example, we selected only journal publications, and we selected publications from well-known publishers. We selected the papers over the past 3 to 4 years, and these detailed results are published in an impact factor journal. So, what is load balancing? Load balancing objective is to distribute the load among the virtual machines such that there is an equilibrium. No host is underloaded, no host is overloaded. They are optimally utilized, and this task is performed by the load balancer. To achieve an optimal solution for load balancing, we need a non-deterministic polynomial algorithm. Obviously, it cannot be done in polynomial time. So we need some approximate solution, and a load balancing solution can be employed in hardware. It can be part of the network or an application running as a software. So this is the block diagram describing there are different users that are submitting the job to the cloud, and then the load balancer's job is to distribute the load among the servers or the virtual machines running on the cloud. Then, after the literature review, we identified that there are different types of load balancing solutions, such as threshold based, static versus dynamic. In the static approach, uh, you just divide the load among the nodes. You don't consider the current load on the virtual machines. So it is a proactive one. Then sender initiated versus receiver initiated. For example, it could be initiated by an overloaded machine, or it could be done by some other machine to initiate the load balancing process. Or in the symmetric approach, anyone, whether the sender or the receiver, can initiate the load balancing process. Then it could be a centralized solution or decentralized solution, and the jobs can be dispatched to the virtual machines in an offline mode or a batch mode. This is the taxonomy that we developed. There are approaches that are classical ones, like these are being used for resource management in operating systems, first come first serve, round robin, minimum execution time, etc. Then there are general approaches like workflow based, map reduce based, and so on. And then there are AI based approaches, which some of them are based on optimization, like operation research based, swarm intelligence based. So this is a very popular approach based on swarm intelligence. And then there are heuristic based approaches, machine learning based approaches. Among them, there are supervised, unsupervised, and reinforcement learning solutions. And there are some solutions based on game theory. So the detailed results are published in our impact factor journal. Then what are the major challenges of load balancing? It includes geographical distribution of nodes. Then the nodes are geographically distributed, so there is an issue, and sometimes there could be a centralized solution, so a single point of failure is there. Then if a virtual machine is migrated after detecting that there's a huge load on a particular machine, we need to migrate the virtual machine to some other host. So obviously you need to manage the context, you need to switch the context, all the contextual information, the register values, the data, all of them are saved and then moved to another node. Then the nodes could be heterogeneous in nature, and also the complexity of the algorithm. It should be a simple algorithm because now for cloud computing we have the concept of mobile cloud computing, in which there could be nodes that have very low resources. So algorithm complexity should also be considered. Load balancing parameters or metrics. There are different metrics such as throughput, thrashing, reliability, accuracy, make spin, scalability. Uh, so these metrics can be used for performing uh, or evaluating different load balancing solutions. Thrashing means when a virtual machine is continuously being migrated from one host to another without performing any useful utility. It is a very popular concept in computer architecture, in which when we perform caching and data is brought into memory and then taken back and then again brought into memory and so on. So similarly, a virtual machine is continuously being migrated from one place to another without actually performing any useful task. Then fault tolerance is if a strategy is fault tolerant or not, migration time, energy consumption, response time, degree of imbalance, and carbon emission. So these are different matrices based on which you can evaluate a load balancing solution. Now let's come to the final part of my topic, which is an LSTM based load balancing solution. So we proposed an LSTM based solution for load balancing in cloud computing. It is an initial work. So we have just proposed the conceptual idea. We have identified that no one has ever worked on using LSTM for performing load balancing. Uh, So the idea is that we can use LSTM, we can use the current load on the virtual machines as a time series data, as a sequential data, and LSTM is ideal for these sequential data. So based on predicted load, jobs can be scheduled. So LSTM belongs to the family of recurrent neural networks, RNN, and RNN has long been used for modeling sequential data. So RNN has been used for sequential data in which the current state is dependent on the past state. So why not we use RNN or LSTM for modeling the load on the virtual machine. RNN has a problem that it cannot be used for modeling long-term dependencies. It has vanishing gradient and exploding gradient problem, and LSTM solved this problem. So the idea is to use LSTM, and LSTM can be used to model the current load on the virtual machine, and based on the past history of the load on the virtual machine we can predict what is going to be the future load on every machine. And if we found that a node will be overloaded in the future, we can switch a job, we can migrate a job from that machine to some other machine. So this is the diagram explaining that there are various jobs being submitted to load balancer, and then there is an LSTM based model, and it predicts what is going to be the load on this virtual machine. Then there is a matcher that can select a particular host based on the required configuration, the desired configuration, and then the load balancer can place or assign the job to that particular host. So this is the basic concept. Now as far as the future directions are concerned, we are going to implement this solution. We have various students working as a PhD student under our supervision in our research group. So uh, ML is emerging as a technique for load balancing. Machine learning is an emerging topic. It has been used for load balancing, fault tolerance, and various other problems of cloud computing. But obviously, we need data. There are not enough data sets available. Then there is an issue of thrashing and false positive. For example, if we predict that a particular node is going to be overloaded in future, but that does not actually happen in the future, so uh, or or vice versa, so there can be issue of thrashing. Then there is an issue of security. For example, a virtual machine is migrated to another host, there could be the issue of security of the virtual machine. There could be issue of the host, that is in which the virtual machine is going to be run, and there can be issue of the underlying data on the virtual machine. So there are three particular issues once a VM is migrated as far as the security is concerned. Then there is a hot topic of research on an energy efficient load balancing. So this is just a brief discussion about load balancing in cloud computing. I hope all of you like it. If you have any question, you can ask, my dear friends. If you have any question, you can ask, or should we move to our next program?
I have a few questions, if I may.
Yeah, yeah, please.
So you showed that you are trying to use machine learning techniques for this load balancing problem, and in the beginning you explained that this is a hard problem. Uh, but I would like to know some results. I mean, did you apply your technique and found some good solutions? What was the accuracy, or if you would like to talk about that?
No, we are actually working on it. We have not yet implemented it. We are working on it. Our PhD students are working. So hopefully we will get the result in next few months. So we will inshallah publish that definitely in some good journals.
Okay, thank you.
Thank you. Okay. So if there are no further questions, then let's move to a next agenda item. And the next agenda item is a panel discussion. And for this panel discussion, we have with us Dr. Shiraz Latif from Economical Insurance Canada. Welcome, sir. Then Dr. Abdul Samad from Habib University, Pakistan, and Dr. Shahid Hussain, who is also assistant professor at Habib University, Pakistan. So the topic of discussion is education in the context of fourth industrial revolution. So my question to the panel, first of all, is to actually let's precisely discuss what is fourth industrial revolution, what technologies are involved. So I would like to request first In the sequence, Dr. Shiraz Latif, please, will you please start with the discussion? What is fourth industrial revolution? Shiraz, we cannot hear you. Actually, there's a problem in your mic. Yeah, please.
Okay, is it okay now?
Yes, yes.
Okay, good. So, Assalamu alaikum, everybody, and thanks, Noman, for inviting me to this wonderful session. Uh, so, yeah, the fourth industrial revolution is, I would say that it's not something that is purely related to technology, but that is more related to your learning habits and how you prepare yourself for the changing environment and for the changing world. No doubt, one part of that changing world is related to smart things, smart technologies, smart grid, smart cities. Everything is going to be smart with the development of Internet of Things. Everything will be connected world, connected things. Uh, and to in order to ensure the success in that world is to rely on your learning, and a major part of that learning will be more collaboration and more teamwork instead of like the normal traditional kind of learning where things were more based on memorization and remembering the stuff. Instead of that, then now the world is moving towards more problem solving and critical thinking.
Okay, thank you, Dr. Saab. Dr. Abdul Samad, can you please comment what do you think by the term fourth industrial revolution?
Okay, so am I audible?
Yes, sir.
Assalamu alaikum. So thank you everyone, and especially Dr. Noman for. Um, okay, so the fourth industrial revolution, as Dr. Shiraz Latif pointed, is it's more about connectedness. Uh, how AI, the other technologies that are emerging like quantum computing, 5G, so how they are disrupting our lives, and how we can maximum achieve the economic benefits from it. So I think it's just like the about how connected we are, and how we can use these existing technologies to uh, uh, improve our existing business and our lives.
Okay, sir. Thank you very much. Yes, Dr. Shahid Hussain, can you please explain for us what is fourth industrial revolution?
Thank you very much. Thank you very much for inviting and conducting this event. I think, I mean, this is my opinion, and you may disagree with that. So if we look at all the industrial revolution starting from the, 18th century or before that, they were based on some innovative ideas in that time. For example, we start with the steam engine, and then we went to, the second industrial revolution utilized the fossil fuel, and they came up with this revolutionary idea that rather than using water, steam to run engines, we can use fossil fuel to run engines. So there was a drastic change. And in the third revolution, which is, I think, has a distinct boundaries again, that we use electronics and our ability to communicate over long distances, and creating these electrical networks, and so many other things. So this was again a distinct jump in that thing. Uh, the the fourth industrial revolution, which is now described as the connectedness of everything, all the devices that we use in our home, in our with us, on our body, and everywhere else. I think it's just a continuation of what third industrial revolution provided us. So it's just a scaled up version of what we already had, like 30 years ago, 40 years ago. So we do not have internet at that time. So now we have internet. We do not we had electrical networks, so we could use electricity at our homes, on streets, in our offices. But on top of the electricity, we also have internet. So we are not just connected by electricity; we are also connected by data. So we can communicate with people on the go. So if I'm moving, I'm going in a moving car, I can still talk to someone else on the other side of the planet who is also moving in a car. So this is a revolution. This is something that was unthinkable, like maybe 100 years ago. So for me, the fourth revolution is just an extension and continuation of the efforts and revolutionary ideas that we developed in last 200 years. Um, and I think all of them revolve around the our understanding of how computer science works actually. So it's more related to the fundamental aspects of computation and how we can get connected with other people. So these are just a few of my opinions.
Thank you very much. There are few questions, but I would suggest that we can have the questions at the end of the discussion. So please bear with us. Let me ask the second question. So that was a very brief introduction about fourth industrial revolution. The uh, panelists just gave their point of view, their opinion. And obviously, there are a number of technologies that are involved, like artificial intelligence, cloud computing, blockchain, Internet of Things, 5G technologies, quantum computing. So, a lot of technologies are involved that are helping us in one way or the other for providing the connectivity, for providing the convenience that we need, for easing our tasks, for automating various jobs, for providing efficient solutions. So now my question is again, are we ready for the fourth industrial revolution? Are we really ready as a teacher? Are we really teaching to our students what they need for the future? What skills are in demand? And how do you see the role of the soft skills and the social sciences in the next industrial revolution? So I would start with Dr. Shiraz again, please.
Yes, so no, Dr. Noman, that is right. That the main concern of fourth industrial revolution or the current modern world is not the exact technology, but more on the behaviors and, as you said, social sciences. So the need is to add more and more emphasis on collaboration and team learning. For example, like when I moved to Canada, the major difference that I seen teaching in Pakistan versus teaching in Canada was that over there we have a classroom where like we have rows, row number one, row number two, row number three, and the teacher try to stop students talking to each other. Whereas here, when I went into the class for the first time for teaching, I seen that the classroom are like there is a circular table where students face each other. They don't face the teacher, they face each other to promote, to motivate interaction, collaboration, teamwork, discussions. Those are the real sense of modern learning, to learn from each other, not to learn only from teacher. Teacher is to facilitate the learning, but learning is something that you need to rely on your own self and your peers.
Yes, Shiraz, you're right. Definitely, we need to improve the way we teach to our students. So there should be more collaboration involved. Yes. Yes, Dr. Abdul Samad, I would like to take your opinion on this point.
Thank you. So there, I think you asked multiple questions, but let me try to answer each one. So I think as Dr. Shahid mentioned that, in fact, there is nothing new theoretically in this fourth industrial revolution. So, for example, just specifically talking about AI. So, the basis of AI are the computational aspects or the theoretical aspects of AI is not something new. People have been working with these methods from like 100 to 200 years ago. So, for example, think about linear regression. So it's nothing new. Uh, what I see that in a Pakistani scenario, that we don't teach the basics. So the basics are really important. So, for example, again talking about the AI, the language of AI is nothing but the linear algebra, probability theory, and if you want to optimize something, then obviously it's a multivariable calculus. So what I see most of the time is that we don't focus on the basics, which is really the key. So, for example, the world is again moving towards interpretable machine learning, where you should be able to explain your model. You should tell what distribution this is coming from, or what are your assumptions, why you took these kind of assumptions, what are your limitations, um, and these kind of things. So what I see that in our academia is that when we talk about AI or machine learning, we directly move to the model development, where these days it becomes really simple in a sense that you have very good programming languages which can really help you quickly with developing the solution. But what I see, I mean, the thing that I can see the lacking thing is that we are actually missing the basics. So in our academia, so I think we should be focusing more on the basics, and then once you know the basics, then obviously you will be able to interpret whatever you are developing. And the I think the second thing, so I think our academia should be teaching how to think about something. And I personally feel that, especially Pakistani academia, the social science aspect, especially in computing schools, they just ignore it. They never discuss it, or they just take it like this is not a necessary subject, or this is not important. But when you are developing solutions in the real life, then you will see you will be developing these solutions for humans. So, so that kind of aspect actually comes from a very good understanding of the social science or an education which is which has embedded a really good skills of social science. So, thank you.
Okay, Doctor, can you uh, I would like to ask you that what do you see the role of the social science in the next industrial revolution? How does the social science going to play the role? Yes, Muslim, we will
Uh,
take your question later on,
okay.
please.
Thank you. Thank you. I think your original question was a question containing four sub-questions. And I think the remaining two panelists have already talked about it. But let me say a few words before I move on to the exact question that you asked me. So the first thing is, are we ready for the fourth industrial revolution? And I think it doesn't matter if you're ready or not. It's like if it is something global nature, we have to be ready. It doesn't matter if we are mentally or physically or ready in terms of our industrial or technologically advancement. So it doesn't matter. If it comes, and we have to cope with it. The thing is that not just this fourth industrial revolution, but all the industrial revolutions before it. They were driven by, I mean, the only driving force behind these revolutions is the economic growth. And that too is basically coupled with the capitalism and capitalistic interests of wealthy few people. So, so there might be an illusion that the world is progressing. We are getting closer to each other. We are progressing. We are utilizing more and more technology. Our lives have improved. But the underlying concept is the same, that we we are working for the few rich people of the world for the betterment. So so if those people have already decided that we have to move in a certain direction, and that certain direction comes with this technological revolution, then definitely we have to go there. It doesn't matter if we are ready or not. The second one, what should we teach our students? So this is again, and this question again depends on what direction we want us to be in, or what do we see ourselves to be in that position. For example, if you want to produce, if you just want to be consumers, and if you just want to be the working class as we have been in last three revolutions, then it doesn't matter what we teach our students. So we will be producing uh, the strength, the labor that the industrially advanced countries would require, and they would just pick those students and people who they think fit in their system, and it doesn't matter. So they would create these niche institutes and niche places where they would teach students exactly what they want to be consumed in their industry. To me, it's as Dr. Samad mentioned, to me, it's more like the concentration and focus on the basics and the fundamentals, which is more important. So as you know, that in last 20 years, we might have used several tools which have now become obsolete. Um, and there was a boom about different programming languages. There was some talk about a few techniques and technologies in last 15, 20 years, which now nobody uses, right? So the thing is that these technologies come and go. The underlying fundamental concepts remain the same. And as Dr. Samad mentioned in last question as well, that this, and I also talked about it, that this fourth industrial revolution is just a continuation of what we were doing like 50 years or 100 years ago. So the concepts, the basic concepts still remain the same. We haven't uh, advanced in our understanding of how computation works. We haven't advanced in our understanding of how communication works. So we might have developed new tools to have a faster, quicker, better communication, but the underlying principles still remain the same. We haven't done any revolutionary work after. I mean, I would say that maybe we have done few things, but nothing revolutionary as what Shannon did, or nothing as revolutionary what Turing did, or after those people. So the fundamental ideas remain the same. So unless we teach our students, unless we motivate our students to think about creating new ideas rather than utilizing the concept developed by other people, we will be still in the same vicious circle. So to me, it's like we should teach our students what is more fundamental. We should let them explore, and we should not just make them users of ideas developed by others. What skills will be in demand? So many skills. I mean, I cannot name some of them, but all of the skills that are, I think, are important for any advancement would be required. But it is now connected with soft skills and social sciences. So at Habib University, for example, you might be aware that we consider social sciences and humanities very important aspect of even for engineers and for science students. So social sciences play an important role. You need to be good citizen of the world. You should be aware of your surroundings. You should know how to interact with people before you could be interacting with science and engineering and technology. So um, it's not just specific to the fourth industrial revolution. It was true 100 years ago. It was true maybe 200 years ago, and it is truer now that it is more important for us to know about ourselves, to be better citizen of the world, to be more responsible about what we do, and we should be aware of our actions and their consequences. In last 300 years, we have destroyed our planet, right? So we have utilized everything for the advancement, and we haven't even thought about how those things will impact our planet, our living on this planet. So we might be at the verge of destruction. So unless we know about those things, unless we read history, unless we know that what are the impacts of blindly going in one technological direction, we might progress for a temporary, for a short time, but eventually it will lead to destruction. So I think soft skills and social sciences are very, very important uh, in this aspect.
Okay, thank you very much. Now, one more question. Since this is a research conference, so I would like to ask you people, what are the some of the key areas where we can pursue research in fourth industrial revolution, specifically for students like masters students or PhD students, if they want to pursue their research, then what are the research areas? And one more question, that if the student wants to have more information about fourth industrial revolution, what are the some of the avenues where they can find useful information? For example, some research groups or some websites like archive.org is there for artificial intelligence research. So my question is this.
So, Noman, yeah, the beauty of this revolution is that you have to you have to focus on lifelong learning. Like it's not as Dr. Shahid and Dr. Samad said that what we learned 20 years back is no more valid. So yeah, the beauty is to be a lifelong learning where you need to focus on three things: learn, unlearn, and then relearn. We are good in learning, but we are not really good in unlearning. We need to focus on that as well. That if we learn something, we cannot continue with that throughout the life. So yeah, we have to unlearn, we have to relearn, and and that is possible. For example, these days there are a lot of MOOCs, online courses. You yourself learned a lot. I keep on visiting your profile. I learn a lot when I moved to Canada. Like the things were completely new, and the major player for our success is our willingness to learn. And there are a lot of resources, huge resources available online. You can take online courses. You the data is readily available. It's only depend on how you are going to search and how much time you are going to spend. Kaggle competition have immense problems available over there. Take the problem, like raise your sleeves and get into solving those problems. So yeah, it all depends on how much time and how much effort you are going to put in those areas.
Okay, thank you. Dr. Abdul Samad, please comment.
Yeah, I think one point that was raised by Dr. Shiraz Latif was lifelong learning. I think that's really the key. That's very important. And while answering case, which areas students should focus on, so again, I think I'll put my bias here. Is that, for example, I'm sort of a guy who actually is interested in more theoretical stuff, even in machine learning, for example. What are the bounds, how to calculate them, what are, so for example, if I have less amount of data, then how much sure I am that how LSTM is going to work. So, for example, these are there are a lot of open avenues in the explainability of neural networks. So I think in deep learning we are uh, something like what happened to us in the physics, that we observe something and then later we develop the theory for it. So I think we have observed quite enough of stuff in deep learning, but we don't have enough theory to support it, that why something is happening. Um, so I think that's a very crucial area where students can focus on. Again, for such explorations, the basic knowledge is the fundamental, and it's important. Again, while answering, I know I have my bias towards it, and there are plenty of resources that students can find. So, obviously, MOOCs. I think on ADX you can find some really good courses which are at graduate level courses that are offered at MIT, Stanford, and the other places. And then there are big giants which are publishing their results, and they are so, for example, like NVIDIA, Google's, and then there are places where you can see how people are actually fitting the models, like Kaggle competitions. So, I mean, there are a lot of places where you can gather information. I think the intent is really important, and do not waste your time. I think one should be really clear enough that what he is really looking on, and he needs to work on that. So, and avoid procrastination. So that's what I can suggest.
Thank you. Dr. Shahid, would you like to comment?
Thank you. Yes, I have one suggestion actually, and it's not just suggestion. It's my opinion as well. Um, and it's not just related to fourth industrial revolution. It's related to what we have been experiencing in the past few years. Um, and with the advent of fourth industrial revolution, we know that more and more connected devices would be there, billions and hundreds of billions of connected devices, mobile phones and computers, and even the appliances will be talking to each other. And all these sensors and devices will create enormous amount of data. So let's say you have huge amount of data that you need to analyze, and as a computer scientist, I know, and I teach also to my students that if I have a huge stream of data and I need to, let's say, find some specific number or some specific packet or some specific data from that stream, I need to at least search all of those items in the worst case. So even the average case analysis of such an algorithm is linear in number of data, the size of the data. So you can imagine that in such situations, even the linear time algorithms are not efficient. They are not scalable. So you can search your number or data from an array or a list of, let's say, 1,000 elements or maybe 1,000,000 elements. But when you scale up at the scale of, trillions of devices, hundreds of billions of devices communicating with each other and creating and generating enormous amount of data, even the linear linear time algorithm will not suffice. So we need to come up with strategies and ideas where we know that where to look for an answer rather than exploiting the entire data stream. We need to look for specific places where our answer could lie. And there are some techniques that we can employ. There are some approximation algorithms. There are some randomized algorithms that we can employ. But to me, it is very fundamental, and it's very basic to think about this problem. Unless we are able to solve such questions, or unless we are able to answer these questions in a very reasonable amount of time, whatever models that we will build, whatever techniques that we will develop, will be at best very bad approximations. So we need to have more insight into such problems. So we need to come up with new ideas that how to search in a huge amount of data, how to utilize a huge amount of data in a meaningful way. So even, let's say, even if you're not just searching it, I mean, searching is just a simple example. In order to come up with any meaningful data model from that amount of data, would require to parse that data, would require to go through that data, then create maybe decision trees, or maybe pass that data to some neural network, or do some any kind of machine learning or artificial intelligence. That would require a lot of, I mean, enormous amount of time. And that time cannot be reduced because we have fundamental limits on computation. So I think students should be looking for studying new ideas and new ways to come up with even more. And they should try to think that how can they solve these problems. So solving those problems, I think, is the fundamental aspect.
Okay, thank you very much. Now, audience, if you have any question, you can ask. Yes, say it, Muslim.
Yeah,
Yeah, please.
yes, I have a question. It was very nice, healthy discussion. Uh, First of all, I want to ask that how far we are from the actual from benefiting the implementation of IR 4.0. We have been taught that okay, it is important, but when we see in the industry, the practical utilization seems a bit far still. So what is your idea about it? First question. And other question is that how important is to address the ethical issues, associated with IR 4.0. These are my two questions.
Okay, to
Thank you.
whom you would like to ask, please mention the person you would like.
Uh, yeah, my first question I would like to ask Mr. Shiraz Latif, and the second question Dr. Abdul Samad.
Yes, Shiraz.
Okay, so how far we are from actually the that is like it's not a something that we say that okay, this is the point where we say that okay, this is the final destination. It's not like that. It is continuous improvement, and world is moving towards that. Obviously we are quite far from that, we means in Pakistan, but the world is rapidly moving towards that, especially the IoTs in developed countries, uh, connected devices, connected homes, connected transportation, smart grids, smart cities. Those are all now practically exist. Uh, Take the example of very minor things at home, your electricity, your electric plugs, your heating equipment, your furnace. Those things are now all automated. Uh, when you go out, you get a message when somebody comes in your home through IP, your cameras, uh, industries, sensors. Industries have sensors, and like when we talk about the continuous growth, it doesn't mean that that gives you the best efficient result from day one. So yeah, we are continuously improving. Like for example, my field is more in solving insurance problems with the help of data. So yeah, there were a lot of insurance frauds. We are trying to overcome those with the help of data, with the help of AI, machine learning models, with the help of installing some sensor in vehicles. So yeah, we are moving towards that. There is no final destination where we can say that okay, this is the final goal. That is based on continuous growth.
Yes, Dr. Shahid, would you like to answer the second question about ethical issues?
Sure, I think that was targeted at Dr. Samad. But anyway, I can answer it if Dr. Samad doesn't want to. Um, Ethical issues. How to solve ethical issues? I'm not sure how to solve it, but I think there are certain aspects of those ethical issues that we have to be aware of. And I think we are all living in a post-Snowden era. And once Snowden was asked about this question, and he said that if you try to listen to any alien civilizations communication, for example, if you look at the SETI search for extraterrestrial intelligence, so he said that it may be possible that if we are able to find out any communication, then that communication must be coming to us from their time when they were not aware of their privacy and security aspects. For example, if you look at our own communication nowadays, most of our communication is encrypted. So if some alien intelligence is listening to our communication, they might be getting some random gibberish. So they might not be able to come up with any idea that what they are listening to. So I think the ethical issues are of multiple aspect, multiple style and nature, and they start from the privacy and security of our communication. But then there are other aspects. For example, uh, if you look at, let's say, Facebook or Twitter or other social media platforms, which we have developed in last like 15, 20 years, and they are advancing, they are progressing, and sometimes in right direction, but there's still a lot of things to do. So the problem is that once you put something online, it stays there. It never comes down. Even if the owner of that data wishes to remove it, if the company or the site where it was posted wishes to remove it, it's in most of the cases it never vanishes from the face of the earth. If it is online, it is online forever, unless all the people have decided to bring it down offline. It will remain online forever. So the ethical issues which are related to, for example, privacy. For example, somebody makes my video and post it online. Even if I don't consent to it, if I don't want that to be online, it will remain over there. uh, so for me, and I think that is also employed by some social media platforms, that they usually screen that content and see if it's anything is objectionable, they remove it. That's something good. We can train neural networks. We can use deep learning. We can use AI and machine learning techniques to automate this process to make it scalable. But then there are again different questions. For example, how we can make sure that the algorithm that we have built is unbiased. It actually detects the problem that we want them to detect, and it's not biased by my company's preferences or my personal taste. So this is very hard issue. So even before we go there and develop such algorithms, we need to come up with some ideas and some agreement on what we are actually looking for, what we should be allowing to be on the internet, and what should we not be allowing on the internet. So, and I think there is no single simple answer to that question, but we need to keep thinking about it, and all the intelligent people of the world should think about it and come up with some good solution. On the other hand, there are other ethical issues. For example, if we go with the autonomous cars, for example, if I'm driving a car and I hit someone, then I'm responsible for hitting that person, right? And I should be liable for all the damages or for anything according to the law. But what if the autonomous car hits someone? Who is responsible? Is it the algorithm that is driving the car, or is it the person who created the algorithm? Is it the company that created the car? And if it is an algorithm, if it is a deterministic algorithm, if it created this mistake, then there is a potential that it will create the same mistake in the similar scenario anywhere else in the world, right? So these are very fundamental questions. So and they are related to ethics and other aspects. So I think um, we cannot solve these questions right now, and we might not even be aware of all the questions, all ethical questions right now. So as the time progresses, we will see those problems, and some people in the world will try to solve them. But what is more important over here is that we should be aware that there will be problems, and we should be ready to solve them. This is more important than solving those problems right now. I'm not sure if that answered the question, but yeah.
Thank you, Dr. Shahid. Uh, and one more ethical issue is about the biasness in the data. If your algorithm is biased, obviously it will give the results uh, it would be much biased towards a specific race, for example, a specific gender. So I would like the comment from Dr. Abdul Samad on this issue of biasness. If you have the biasness in the data, this would be a ethical issue.
Yeah, thank you, Dr. Sam. So, yes, apart from other ethical issues, one of the main issue is the biasness of the model, and I think it has been observed many times that, for example, when one company actually developed a solution which was actually looking through the CVs of people, and that particular model was actually only uh, was biased towards male more because historically more males were actually in that particular industry. So yes, and I think it's something that we have to really think about it and come up with some out of the box solutions. But again, uh, to solve such things, again, I would insist on the basic theories. And apart from this, I think the other issues those will rise and which need to be discussed is, for example, unemployment. So what's going to happen when these jobs end? So, for example, with these self-driving cars, uh, uh, it's going to finish a lot of jobs. So we don't have any solutions for it. That what its impact will be on the society, and what should we do? It can also create inequality of how to distribute wealth that's being created by machines. So it's also going to create inequality in the society. Plus, it's going to also, I think, affect our behaviors and interactions. And it's going to, so it's kind of also pointed by some people that it's going to make us just make us more goof. So there are multiple. I think there are different aspects in terms of ethical issues. I think, as Dr. Shahid mentioned, is that we should be willing and ready to solve them as they emerge, because there are some issues which we don't know right now, but that they are going to appear. So yes, there are ethical, a lot of ethical issues related with it, and this is, I think, something which we are not focusing, or even the academia is not focusing on it.
Okay, thank you
May
very
I,
much.
may
Yeah,
I add something to it?
yeah, please.
Okay, so when we talk about the biasnesses in, let's say, machine learning algorithm, as the Dr. Samad mentioned, one example of series, there are multiple different examples. For example, if you're applying for a loan and you belong to a certain race and certain neighborhood, then your application might be denied based on machine. Let's say if that thing is modeled by machine learning. So there's this biasness in algorithms. And this is more prevalent in United States and other places where these things are automated. And we know that there are certain races which are neglected. And if you are living in a certain neighborhood, then you will be most probably discriminated against. So there are algorithms which detect some discrimination, and they do something to, avoid it. But the problem is not just that we don't have unbiased algorithms, but the question is even more fundamental. That is, what if we do not have a machine or an algorithm deciding it? What if we have humans behind this data, and what would they be doing? If we can come up with some strategy, come up with some ideas that we eliminate discrimination, eliminate these biasness in our decisions, then only we would be able to include and implement those ideas in our algorithms. So unless we are unbiased, our algorithms will always remain biased. So there is no way we can eliminate all forms and types of discrimination.
Very good. Yes, any other questions from audience?
Assalamu alaikum.
Well,
Yes, Dr. Khan, I have one question in
yeah,
general.
please.
That cellular communication has an important role in IR 4.0, because as we know that when we are talking about the IR 4.0, then M2M communication is there, and 5G is playing very important role in this. So when we educate the people regarding Industrial 4.0, so I think we have to also educate people from 5G perspective as well. And the second one is, if you please light on entrepreneurial behavior of IR 4.0, because when we are teaching the people about IR 4.0, what we can say that, or we can uh, told the people that they are getting job or losing job.
Okay, I think the first question, may I ask Dr. Shiraz Latif to answer, and the second question may be answered by Dr. Abdul Samad, please.
Okay, thank you.
Sorry, Dr. Noman, I think you will have to repeat the question for me.
He was talking about cellular communication, that we need to educate the people about the use of cellular communication. That is what something. Am I right?
Mhm.
Yeah, yes, Dr. Noman. I am talking about the machine-to-machine communication, because when we are talking about the Industrial 4.0 or IR 4.0, then it means M2M communication is there, because automation is not complete without M2M communication. So, and when we talking about the M2M communication, 5G is there, or we can educate. We have to educate people from 5G perspective as well.
Yeah, so yes, when all the devices, all the thing, everything is having a like IP, everything is smart, everything is able to communicate. Definitely, there is a communication between machine to machine. Definitely. So sometimes that need human intervention, but when most of the time it may not need human intervention. And in that case, then like, educating people on 5G, like communication is definitely the backbone of all this revolution, whether it is uh, even when it is to human communication, still it will be through some device. And so those communication will need all the things like if it is wireless communication, you need to understand that. If it is different routing algorithms, the people who develop, who design those things, so there are different like streams and different divisions of revolution. Those people who work on the front end will have different expertise, different technologies as compared to who is at the back end. So yeah, you need to you need to uh, you need to focus first of all on what you are interested in, and then you can take it towards more deeper level. So definitely communication, whether we name it 5G, after some time it may be then 6G, but yeah, the communication is the backbone.
Okay, thank you, Dr. Shiraz. Dr. Abdul Samad, would you like to comment on the second question, the entrepreneur part of the fourth industrial revolution?
Uh, okay, thank you. So again, I don't see it this mindset as a separate entity, or we need to train students separately for this thing. Again, it's just a part of the package. I think our academia should be good enough that it teaches the basics, the implementation, and the social skills, and then on the top of those things, I think you can think about these things. So I think it's just a package.
Okay, thank you very much. I think we are short of time, so I think we should wind up. Thank you, Dr. Shahid Hussain, Dr. Abdul Samad, and Dr. Shiraz for joining us. And thank you, audience, for joining us. Again, I would like to thank Dr. Shiraz, especially because this is, I think, 1:30 a.m. there at the night time, and he has joined us from Canada. So, a special thanks to him, and thank you all. Uh,
Thank you.
Inshallah,
Thank
we
you
will
very much.
join in the next day tomorrow at 9 a.m. For the workshops. We will have workshops on Python, TensorFlow, and web scraping. So, if you would like to join, please. Thank you very much for joining us. Allah Hafiz.
Thank you very much, Dr.
Thank
Noman.
you. Take care.
Allah.
Thank you.